Oh, yeah, 116 talking about WebSockets. All right, let's get into it. Let me hit refresh over on this thing. And I have to update the grader for today's lecture question still. So if you're one of the first ones submitting, the grader just it's got a bug in it. I'm still making sure it's gone, making sure that bug's gone. So you might not get an accurate grade until after the Q&A today. So today's lecture question, though, is to spin up a WebSocket server. You're going to listen on port 8080 and listen for just one message type. Whenever you get a message of type increment with no data attached to it, you're going to increment an internal counter and then have one method named number of messages that returns the number of times you've received the increment message. And notably, number of messages, this is a regular method. This has nothing to do with the WebSocket side of things. The only message you're listening for is of type increment. So listen for one message type, react to that, and then have this number of messages returning how many times you've received that message. So this is what we want to build today. It's a very bare bones WebSocket server. Then we'll start working with WebSockets. So this is ultimately what we're going to be seeing. I just want to flash this image now, but we'll build the rest of this over the next 2 weeks. This isn't strictly part of this learning objective. For this learning objective, we'll focus on these two pieces. My mouse is on the right screen, right? Yeah. We'll focus on these two pieces. The actor system we've already talked about, and the WebSocket server we're talking about all this week. And then for this round of homework assignments, which should be up before Wednesday's lecture, so I can talk about them on Wednesday, we'll have both of these pieces work together and communicate with each other. So the WebSocket server is communicating with your users, and the server is going to send actor messages into the system for the system to be able to do what it needs to do. And then the actor system will communicate with a MySQL database, which is stuff we'll see later on. For now, we want to focus on what is a WebSocket, and Nildham 2121 nailed it right there. What the hell is a WebSocket? That's what we want to talk about today. So this is what we're talking about today. And the front ends, we'll talk about them this week in lecture, and I'll show you the front ends, but you won't be responsible for building front ends in this site. We're going to be building the socket server, and then I'll, just like I've been doing for the homeworks, I'll give you the HTML and the JavaScript and everything on the front end. And for desktop front ends, how to connect using Scala to a WebSocket server to build desktop GUIs that are web enabled, things like that. We'll talk about those, but you won't have to unless you choose to as your project contribution when we get to that part of the class. But this part, this is where we're using the event-based architectures. We have a server with users connecting. Every time a user takes an action communicating with the server, that's going to be an event. And just like actors, we're going to work with events as messages that are sent. So it'll have a very similar flavor to the actor system, which of course is not by accident. I want to try to keep things consistent enough so we can get this idea, this concept of event-based architectures in our heads. So what's a WebSocket? Before I talk about that, I want to talk about the problem we're trying to solve here. So in 1.15, you built HTTP servers, and you had some functionality with those. You would serve up static files. You'd serve HTML, CSS, JavaScript, which is actually something we won't. Maybe I'll talk about that during that last week of classes, but I won't talk about that explicitly this week. How to do that. But I'm getting sidetracked. My mind's thinking of something else there. So you handled these HTTP requests. Some of the requests were saying, give me your HTML. Some of the requests were saying, go access this API and send me back some JSON data. But you were handling these requests, and we had this problem of when a client wanted more data from the server after the page loads without refreshing the page, how do we get that extra data? For that, we would make an AJAX request. We would make another request after the page loads, get the response, the HTTP response, read that information, and then handle that information as appropriate. For 1.15, you were getting data from the API for your project, getting data from that API, having your server access the API, and getting that information. The problem with this was the problem was, which was something you didn't handle in your project, unless the specs for the project changed. I haven't looked at the most recent ones. I don't think they have, though. But at least in lecture, we showed a chat app. That chat app had this problem where we have time, the factor of time in here, where if somebody sends a message to the server after a client loads the page, they need a way of accessing that new information without, most preferably without the user taking action. So the first time you see this, there's a refresh chat button. You click the button, it makes an AJAX request, and then you get the response and get the new chat messages since the last time that you refresh the data. That's okay, but let's be honest, you're not going to use a chat app that does that. If on Twitch chat we all had to keep clicking refresh to get the latest messages, that's kind of useless. It's just not a good user experience. So what we did was use something called polling, where we wrote some JavaScript that had our clients send an AJAX request to get the latest chat at regular intervals. So if you have it set for like 1 second, every second you're going to ping the server, say, hey, you got any new chat for me? And then the server can respond. This was our solution to that problem in 1.15. And we mentioned, this might have been cut from the class actually, but if it wasn't, it's just a very brief mention in a slide, that long polling exists, just like it's going to be a brief mention in this slide as well. There is something called long polling where you make pull requests at longer intervals, say 15 seconds. You make a pull request and the server just hangs. It just waits and doesn't respond to that request until it has information to send. As soon as it has information to send, it'll respond to that long pull. And then you can have more real-time interactions without having to wait that 1 second. So the pull request is just making AJAX requests at a fixed interval, at regular intervals. That's what the polls are. So the polls would be a request to some like get chat history path, if we're thinking of a chat app, and then the server would respond with all of the history for the chat. So if you have a new message, if somebody sent a new message since you loaded the page, that next pull request after that new message has been sent is going to respond with that new message, so you can have the latest updated chat. In long polling, similar, but it's faster. So the problem with polling is, say your interval is set to 1 second. Every time you send a request, you might be getting information that's up to a second old. So this will work, but there's going to be some delay in the information up to whatever your pull interval is, and you can lower your pull interval. So maybe you want to send a request 10 times per second, say. Once you do that, though, you're really increasing the network traffic and the load on the server. If every user who's connected is sending 10 requests per second, that adds up. Even at 1 per second, these requests really add up to the point where the first time I did an app with polling and made it live during lecture and had students connect to it during lecture, I had my polling set to 1 second, I believe. And I got so many requests during that lecture because so many students were playing with the app, of course. There were so many requests from the polling that my DigitalOcean, who I'm paying for server for my web server, DigitalOcean actually shut down requests from UB because they thought it was a DOS attack, because so many requests were coming in at such a rapid rate that DigitalOcean just started blocking those IP addresses, any IP address that was for UB. So the requests can really add up if you want any reasonable amount of performance. Anyway, it's a little bit of sidetracking, but polling, not the best solution. Long polling works. Long polling is a lot better, but it's a lot trickier to set up. It's something that we won't really talk about. It's kind of an old solution to this problem. The new solution is WebSockets, of course, what we're here to talk about today. So WebSockets, what are these? Let's talk about that. Is updating chat in real time out of the scope of what we're doing? No. You mean we deal with pull requests whenever we use set time interval? Yeah, so the time interval, or the set time interval, I'll assume you're talking about set interval, the JavaScript front end method, right? So if you do set interval, and then the function that's going to make your AJAX request as the function, and then some number of milliseconds for the interval itself, that's your polling. That's setting up the polling. That's exactly what I'm talking about. Yes. So now we want to talk about WebSockets. And Chewy Skittles, the reason I'm not giving you a more in-depth answer is that's everything we're talking about today. This is why WebSockets. This is why we're pulling these in. So WebSockets is a newer solution from 2011 for this problem, which is fairly new in terms of, it's pretty old in some respects. The internet moves so fast. 2011 was forever ago, but new in other aspects. Because once this was standardized, then each browser has to adapt WebSockets as well. So anybody with a browser before 2011 has a chance of that browser not supporting WebSockets, which, believe it or not, there are users out there with really outdated browsers that they're not updating. A lot of users just don't update their machines that often. If their machine's more than 9 years old, they might not have support for WebSockets. So it is still newish that you have to be concerned about support when you're using WebSockets out there. These days, 9 years, these days, most sites are comfortable just losing those users, I would say. I don't know. Maybe that's too strong of a statement. For what it's worth, Facebook still uses long polling. If that says anything about their user base or what, but it doesn't, I don't think. But I don't want to go down that tangent too much. But since I mentioned, I feel like I have to. I feel some obligation to say this. The Facebook engineers, the engineers that built Facebook, built it before WebSockets existed, so they had to use long polling. And once WebSockets came out, that's a lot of code to rewrite just to use the newer standard. They said, long polling is working for us. Let's keep using long polling. If it's related to lecture, because I'm reading the chat while I'm lecturing, so it does get distracting. But Discord's open. If you head over to Discord, you can just bullshit at Discord. But if you have something where I need to see it, post it in Twitch chat. And then after the Q&A, then you can, then it's all bets are off for Twitch chat. But I want to try to stay on track. I have enough trouble distracting myself during lecture because I just want to talk about all this other stuff. So let's try to keep this on track. So WebSockets is the answer to that problem we set up earlier. It's going to replace polling, replace long polling. It's a way to establish a two-way stream of communication that persists between client and server. So when you visit a site that uses WebSockets, like Twitch chat itself that we're just talking about, Twitch chat is using WebSockets. You're connecting to the server. There's a persistent connection. And then whenever somebody sends a message to Twitch chat, the Twitch WebSocket part of their web server is going to broadcast that message to everybody else who's connected to chat. So we get this instant communication. And importantly, something we never had with HTTP is that the server can send updates to the client unprompted. So with HTTP, we always have to have a request and a response. So everything's client initiated. But now with WebSockets, when the client initiates a WebSocket connection, and once that connection is made, the server can send information to the client at any point in time. So now we don't have to worry about always having an HTTP request so we can respond with information. Now it's the server has something to say to the client, say it right away. And with this communication, with this setup, it's going to be very similar to actors, which is why we're talking about these two topics together, is that we can have the server and our clients all communicating with two-way communication, and then each time a message is received, we're going to react to that event with some code made to handle that specific message type. And yeah, the client can also communicate through the WebSocket. So when you typed that message in chat, you use that WebSocket connection to send that message to the server. And you can actually open up your... I don't want to go down this rabbit hole too far right now, but we can go a little bit, just in case you want to play with it. Have I never gone to Twitch on this browser? There's so many different machines and browsers that I'm using for different purposes that I forget which one I use for what. So if you go to your network tab, refresh. I'm going to sort by status so I can get the WebSockets. Whoa, 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 whoa. Yeah, modern web apps have lots of stuff going on, as you can see there. But if I open up my... I am logged in. I was at Twitch on this. But if you log in and you check out your WebSocket, you can see all the messages that are being passed. So every time somebody sends a message, I get this information about that message when they're sending it. So if I open up the chat, so we can see all the messages here, of course, but you can also see all those messages coming in over the WebSocket as they're coming in. And then if I don't want to chat in here, I don't want to just bomb somebody's channel for an example, but if I send a chat message, it'll show up here. It'll say sending to server, this message, where all these messages are coming from the server. But you can check out all the messages. And if you want to do like how we have the mods just deleted a message, if you're ever wondering like, oh, what was that message? If you have your terminal open, you do still receive that message. It's still on your machine. If you have your terminal open looking at the messages, you can still go back and read that message. But the way Twitch handles it is you'll get another message when a mod deletes a message that tells your browser to remove that message. But you still receive that message. All the information is still there. You can still check them out if you're really interested. Oh, that one didn't have to be deleted, Lana, but yeah, it's fine. But oh, Mike. All right, so let's get back on track here. So this is going to give us that two-way communication and real-time chat app. So any modern site with a real-time chat feature that I'm aware of is using WebSockets to get that two-way real-time communication. And really what this enables us, thinking back to the motivation in 115 of building the app with Ajax and polling, is to get our get our users being able to communicate with each other through the server. And when one client sends a message to our server, we want to broadcast that to all of our clients immediately. It's one of our big features that we want. If we want interaction between clients, it's what we have to do. And if we want, like the maze solver, how we have, if you open multiple windows, you can have multiple players. It's all a multiplayer app. If we have that working through polling and we're waiting a full second before we see other users' moves, other users' current location, it's going to be unusable. Polling for chat, not too bad. But if you want to build an MMO and you're using polling, it's just not going to happen. You need faster round trips. You need faster turnaround times and faster updates. And sockets can get us there. Sockets get us that functionality. So we're going to... it's useless. So we're going to pull in a library. We're going to use something called Socket.io for this. Socket.io is an extra layer on top of WebSockets, which are going to do just a few convenience things for us. So if you're wondering why we're pulling in this library, because we can use raw just WebSockets, we want to use this one layer that's going to maintain our connections. If something happens with the connection and something's disconnected, the client is going to send reconnection requests until that connection can be established again. It also sends messages to make sure that connections are still alive through functionality through this library. And and also adds message types, which is, I'd say, the biggest reason why to use this library in 116 at least, is it adds message types, which are going to give us a feel more similar to the actors that we have. So the message type and the message are always going to be strings here, but we're going to send messages with some string type and then some string message attached to that type. So we'll be communicating with strings. Again, this is the internet. Just like in 115, if we're sending information over the internet, we're going to speak in a format that everybody can understand, and string is a perfect candidate for that. So our JavaScript in our browser speaks strings. Our Scala speaks strings. So guess where this is headed? Back to JSON. We're coming back to JSON with this one, which you can expect in this next round of homeworks, which I'll have up, I already mentioned that, right, by Wednesday. One of them will be a clicker game, and the other one is most likely going to be the TA management system, though I kind of want to swap that one out just because we don't really have TA office hours like that anymore right now, but it is what it is. And then we're going to add listeners that are going to listen for specific message types and then react to those message types. So we should see lots of parallels. The reason why I'm talking about these two topics together, should see lots of parallels to actors as we're going through this. And my hope is that as we're talking about WebSockets, that actor stuff, which probably doesn't completely make sense yet, starts to click a little bit more now that we see another example of that. And by the way, I did see, I just checked before lecture, there are quite a few responses to the lecture question from Friday, that Piazza post. So we can talk about that during the Q&A. If not, I'll get back to the Piazza messages also. But sounds like there's a lot of questions, a lot of discussion that needs to happen with that lecture question. As expected, that's a tough one. That's really testing your understanding of actors. All right, so this is the event that we're reacting to. It's still messages. We're going to react to these messages that occur and run some code when that event occurs. So we have a new library. The dependency, it's out there. It's in the pom.xml in the examples repo, and I believe I didn't remove that link. That link should still be on the course website to be able to get the library itself. So pull in that dependency, run Maven if you've been using a trimmed down POM. If you've been using the one from the examples repo, you've had this library the whole time. It's already been downloaded and installed. All right, so let's jump into some code and talk about how we're going to build these things. So here's part of a server. This is setting up the server. This isn't the entire thing. These listener classes, for example, are also part of the server. But this is the main structure. We'll talk about this one piece at a time, and then I'll pull in the listeners in later slides, and we'll see what those look like as well. So we're going to start with our imports. We're going to use this library. I'm using all kinds of different classes from this library. There's a lot of information that we're pulling from this library that the library is doing for us. So let's pull in these packages and then start setting up our WebSocket server, which is going to listen to WebSocket connections. So first, we're going to do a little configuration. What's the host and the port number that we're going to listen on? For our purposes, we'll listen on localhost, and we'll always use port 8080 in class, just to keep things consistent. I'll use port 8080 on my examples, and in the submissions, anything you're submitting that has a socket server, it's going to be 8080. All my testing is 8080, just to keep things consistent, so we're not questioning. So I'm not changing the ports across assignments and stuff. For your testing, if you want to change the port number, most valid integer values work. And if your int values are fairly high, in the at least thousands, it should work well for you if you, for whatever reason, want to change the port. Sometimes if your server doesn't shut down gracefully, you might want to change the port if that port's already taken by your server that didn't shut down properly, which if that starts becoming a problem, we can talk about it a bit more. The host name does matter, but if it's always localhost means run it on this machine, and I don't have any domain names set up, which is pretty much always going to be your case for this course and for just testing things. Even when you go to deploy, usually localhost is all you need here. Because you have a proxy server, now's not the time to get into that, though. But localhost means listen on this device, on this machine. All right, so let's start creating so this configuration, if you just leave that's what I'm saying. If you leave this configuration exactly the same as you see it here, you should be fine with that. Now let's set up and run the server. So we're going to create a new instance of the Socket.io server class. We're going to give it our configuration, and then it's going to start this. It's going to initialize the server, set up everything that it needs to set up to be a socket server, and then we're going to call server.start, which is actually going to spin up that server and get it running. So once we call server.start, it's going to run some initialization code. It's going to set everything up, and then it's going to be listening for connections on localhost port 8080 after that. We're going to be ready to accept clients, to have TCP connections, and to send WebSocket messages back and forth. We're ready after that start. So the next question is, what do we do when we receive a message? And that's the rest of this code. Or rather, what happens when an event occurs? When we have an event, what do we do? How do we handle that event? And we're going to see 4 different events that can occur for this web server. Either a client connects, a client disconnects, a client sends a message of type chat message. Again, we'll stick to chat servers here. And receiving a message of type stop server with no information attached to it. So we'll talk about all 4 of these things. So connect and disconnect. We're going to go to our server and call the add connect listener or add disconnect listener to be able to add these listeners. And I forgot to mention it by name, but we'll use listeners, which is a common thing to call these. We're going to have listeners which listen for certain events. So add connect listener, we're going to give that an object that is of type connect listener, and this object is going to be notified whenever the connection event occurs. So when a client connects to this WebSocket server with a WebSocket connection, the connect listeners, any connect listener added to this server is going to be notified. Hey, somebody, just letting you know, somebody just connected. So run your code, and that code that's going to be ran is the onConnect method. So we need a class, or rather an object eventually, of type connect listener, which is part of the library. So we're going to extend. You could use anonymous classes, but I think the syntax is a bit too confusing for what we're talking about here. I actually did use anonymous classes in this course before, and I think I do still show one. I might have removed them all, but I might still show one in the GUIs lecture, which I might, even if I do, I might remove this semester. Anonymous classes are just a bit, the syntax is a bit too confusing. I want to expand it like this to show what's going on with that syntax. So I'm going to create a new class that extends connect listener, because I need a connect listener here. And then I'm going to override the onConnect method, which takes a Socket.io client. So once I extend this class and implement this onConnect method, this is what's going to be called whenever the connect event occurs. So when a client connects, the server is going to go to any connect listener, and we could have multiple connect listeners if we'd like. But I'll just leave it at that. You could have multiple connect listeners. Every time you call add connect listener, it's going to be added to a data structure of all the connect listeners. So when the connect event occurs, a client connects to this server, the server is going to go to every connect listener and call its onConnect method with a reference to the client's socket. We can think of this Socket.io client similar to an actor ref, where we have a reference to that socket, and we can use that reference to communicate with that user, with that client. So we have a reference to their socket, and then we do whatever we need to do. Here, I'm just printing that they connected. So I'm not really taking advantage of the functionality. I just want to show you the structure for now. So once they connect, I'm just going to print, hey, someone connected. But this is how we do it. We have some polymorphism, some inheritance to use polymorphism, overriding a method. We have some of those OOP ideas coming back. Disconnect listener, very similar thing. Add a disconnect listener. We have to give it a disconnect listener. So we're going to create a class, extend disconnect listener, override on disconnect, which also takes a socket.io client, and then do whatever we need to do on disconnect. So this is where we can set up data structures. If we want to track each user as they connect, when they connect, we're going to say, set up some data structures storing some information about this client. Then when they disconnect, we'll clean up those data structures and say, okay, we don't need to know about this client anymore because they disconnected. Clean up all that information. That's where we would use these connect and disconnect listeners. Before we jump into there, let me go back here and make sure we have the whole picture. We're creating the server, and then for each event that can occur, we're going to add listeners that'll listen for those events. So we create our server, and we say, hey, when somebody connects, call this class's onConnect method. When somebody disconnects, call this class's onDisconnect method, and start the server so we can react to those events and have our custom code called whenever those specific events occur. Mr. Muffin, depends what methods you mean. The add connect listener and add disconnect listener, no, we don't have to create those, but all the other methods that we saw, you do have to create. These come with the socket.io server class, which we're pulling from the library right here. So these methods are already defined in the library. But this connection listener, and disconnection listener are classes I wrote. So those classes do have to extend the library classes, connect listener and disconnect listener. Connect listener and disconnect listener, those are classes defined in the library. And they have this onConnect and onDisconnect methods, abstract methods defined or declared. We have to define them. We have to say this is what you actually do on connections and on disconnections. So these methods we have to write. Yeah, not a new instance for every event. We're creating one new instance when we set up the server, and then each time the connect event occurs, it's accessing this object that we gave it and calling its .onConnect method with the client. But it is the same object each time. We're only creating the object once. So if we wanted, say, some state variables in this class, we could create those and have those persist across all connections. So if we wanted to track information in the listener, which there might be an application to do that, but if you do want that, usually you'd store it in the server itself, that extra information. And we'll see examples of that. What I like to do personally is store data in the server itself and then pass a reference. Oh, actually do it right here. Pass a reference to the server to the listener class so the listener has access to all the information of the server. And then pass that in the constructor here. And then it has access to everything that the server has access to. You don't have to worry about passing too much information or tracking information in different places. Keep all your data all in one spot. But we are creating new instances for every server, which will just be one for each program. Unless you're doing some really crazy stuff. All right, so now that we're connected and we can disconnect, we have code that can run based on those two events. The next thing we want to do is add some more functionality, add the two-way communication here. So to receive messages from a client, when a client does something other than connect and disconnect, that's not too interesting. But when they actually send us some information, send us some messages, and trigger some events on the server, how do we handle those? And for those, we're going to add event listeners. And we're going to specify 3 pieces of information here. So this is a little bit more involved than connecting and disconnecting, which is just a connect or a disconnect. Here, when we have an event that we're listening for, we're going to listen for the event type, which is going to be the message type for our cases. The message type that the client sent us. So if they sent us a chat message, for example, we're going to respond to that specific message type using this event listener here, this line. We're going to specify the type of the data we're receiving using this class of and then the class that we're expecting, which for our purposes is either going to be string or nothing. We're going to stick with just those two as our classes that we're going to receive. So we either receive a string or nothing. We'll talk about the differences there. We'll receive a string, and then finally the actual event listener that we're going to call, that we're going to access when this event occurs. So for message listener, we're going to create that class and have its onData method, which is going to be called when this event occurs. So when a chat message is received, we're going to use this handler and expect it to be expecting a string. So for this, we're going to extend the data listener class. We're going to extend the data listener class, and that class is going to take a type parameter, which is the type of the message that we're expecting to receive. So we're expecting to receive a string whenever we receive an event or a message of type chat message. We're expecting that to be a string. So whatever listener we give it here, that better have a type parameter of string. We're going to extend that and implement its onData method. The onData method takes a reference to the socket, just like I think should be on the next slide here. It's going to take a reference to the client's socket, just like the onConnect and onDisconnect did. It's going to take the data that we just received of the type that matches the type parameter. So the data, the type parameter, and the class of here all have to match. These all have to be consistent to the type that we're expecting. Chat message, we're expecting the client to send us a string. All these have to be string. Chat message would be like the type of the case class in Scala actors. So this would be like receiving a case class of type chat message, which has one constructor parameter, and that constructor parameter is of type string. That's the parallel that we're drawing here. So we receive a message of this type. In Scala, we would say, with actors, we would say receive if that type case chat message of type chat message, and then run this code and access the chat message's actual message as a string, and then handle that however you need to handle it. Add it to your database and broadcast it to all the users. So we're accepting information of type string, and since we're only working with strings, these strings will often, as we progress, as we want to communicate more complex information, these strings are going to start being JSON strings. So that JSON stuff's coming back. We're at that part of the semester where things are starting to come together. We're going to start seeing OOP. We're going to start seeing functional programming. If you haven't felt that way already, a lot of these things are going to start combining. Nice. Hey, we got some useful stuff. And yeah, anything. By the way, I don't want people to get scared when we're like, hey, keep the chat on Discord and stuff. If it's related to what I'm talking about, by all means, please talk about it in Twitch chat. Just when it's not related to what I'm currently talking about, that's when it becomes an issue. But we're going to get the string and then handle that data however we want. So I'm just printing it, saying I received a message from the socket. This next line I'll talk about in a few slides. This is how we're sending information back to the client. And I think I'll jump around a little bit on my slides just to get the information in the order I want to talk about it. And then we also see this other event, stop server, which is going to stop the server here, so to do a graceful shutdown of the server, so we don't have that blocking port issue that I briefly mentioned earlier. If that does become something a lot of you start seeing, which is fairly likely, I'll talk about it more in depth, but right now it won't really mean anything to you until you start playing with these things and start running up your own servers. So here, when we receive this message, this is more like receiving a case object in Scala. So if we receive stop server of class nothing, data listener of type parameter nothing, data of nothing, this means we're not expecting any data attached to messages of this type. We're going to receive a stop server message that we're handling like a case object. So chat message is like a case class with one constructor value of type string. Stop server is like a case object of type stop server with, of course, no constructor and no other functionality, just a message type, just kind of a signal message. Hey, server, you should stop. We don't need any information attached to that one. So I don't have anything in data, so data is useless here. But we're going to get that message and say, okay, let's stop the server at this point. And these are the two patterns that we'll see, either receiving just a message or just an event, or receiving a message or an event with some string information attached to it. These are the two different things that we'll see. Are these classes in the server class or separate? I define them in the same file, but you don't have to do that. They could be in separate. Wait, let me answer the question more directly. They are separate classes. I happen to define them in the same file, but they can be in separate files as well. But I have them as separate classes. They could also be in the class. They could be subclasses if that's how you want your structure set up. All would be valid options. But in the repo, I have them as separate classes, but in the same file. Just the way I decided to set it up. I didn't really weigh the pros and cons or anything. I just wanted all of them in one place mostly. And I don't know, I didn't subclass them because I probably thought that would be a little confusing, I guess. And the ACK request, thanks to I don't know you 1, 2, 3, 4, 5, 6. ACK request is something we're just not using. So we're not going to use that in this request, in this class. This would be if the client wants an acknowledgement that you did receive the message. You would use the ACK request for that. Some we're not going to use. It's a feature of the library that's there. For our purposes, we're just not using it. It's not necessary for this. If a message wasn't received properly, we're just going to notice that the app is broken. But that's a feature you might want to use in a production server in a large-scale app. You might want acknowledgments that messages were received, especially if it's a message that you're not responding to. Like stop server, we're not responding to the client. Whoever sent us this message, we're not sending them anything back. That would be one case where we might want to use an ACK request to give that confirmation back to the client that, hey, I did receive your message. I did stop the server. Just letting you know, just informing you. And finally, the other side of the direction. Really, I saved it for last, but it's really the big reason to pull in WebSockets is to send information back to the client. So at any point, this doesn't have to be in a listener. Just anywhere in our program where we have access to a client socket, we can call the send event method and use the same structure as we use for our messages here. Just sending messages, creating events instead of reacting and handling events. So if we want to create an event for the client to respond to, we're going to send them an event. We're going to send either one or two strings. The first string, if we're the only string, if we're only using one, is the message type. And the second string, if it exists, is going to be the data attached to that message. So here I'm sending an event of type ACK and sending this as the string attached to that message. So on the client, this would be the other side, or rather if I'm sending this to another Scala server in the same structure, they would have an event listener listening for messages of type ACK, of type string, and then they would have a listener listening for strings, and in that data, they would receive this information right here. And they would handle that however they handle it, whatever they need to do. Can we take a look at the case chat message to see what's going on? So chat message is just a string. There is no class, but the analogy to actors is this would be a case class. If this were an actor system, we would have a case class named chat message that has one argument and its one parameter in its constructor, which would be of type string. That doesn't exist, but that's what it would be if we were building the same thing as an actor system. So if we want to think of this as a case class and this is a case object, that's where the parallels. That's where I'm making the parallels, mostly to show you, hey, this is the same concept we talked about all last week. We're just using it. We're applying it to a different application of WebSockets instead of with an actor system. But we're still talking about the same thing. This common thread of event-based architectures is what we're talking about all these 2 weeks. So I'm making those parallels, but there is no case class named chat message. The message types, when we're talking about these WebSockets, specifically using the Socket.io library, the message types are just strings. So there's nothing extra to define. We just add a listener for a specific string, and then on the other side, on the client side, we're just going to write our code consistently to send messages of that same exact string. So somewhere on my client side, I have to be sending messages of type chat message and stop server, and they have to be listening for messages of type ACK. And if I have one little typo in that string, the app doesn't work. Whereas the case objects and case classes, one big advantage we get there is if we have a typo, we're going to get a red line. The compiler is going to scream at us. It's going to let us know we did something wrong, so we can fix it. So start and stop are like object, and send messages like a class. So any message. Yeah. So the stop server is like an object, and chat message is like a class. But not start. We didn't start the server that way. This is actually the actual functionality of these two messages we're not really talking about right now. The stop server is something we probably won't actually use in the class, but something I wanted to set up just as an example of a message that doesn't take any information. And let's quickly see the demo. Then we can play around with the demo a little more during Q&A. And of course, Wednesday and Friday we'll be playing around with this same example. So I have my server. Configuration. Same stuff that we saw in the slides. Oh, I think it's character for character. So now when we want to run the server, which you've been doing for some of the homeworks. Oh yeah, that's fine. Blah blah. Sounds right. Okay, yeah. So once we have this, and you've been doing this for some of the homeworks, depending on your choices, you've seen this. You're going to run the server. We're going to see listening on port 8080. And then we're going to go to our HTML, the front end of this, which I'll just quickly show some of the other side of this. Wednesday's lecture is all about the client side and talking about the JavaScript side of things. So I'll just quickly talk about it here. We're going to connect to that server, port 8080. We're going to specify that always use WebSockets. And when we receive that ACK message, we're going to just display that in our HTML. But we have similar syntax here. When we receive a message of type ACK, we're going to call this function to respond to that event. When we receive a message of type server stopped, which our server doesn't even send, so actually does it? I'll have to double check. But when we receive that, we're going to just let the user know that the server stopped. And when the client sends a message, we're going to use this emit method, which is going to emit a message type, and this is where we have to make sure our strings are matching exactly. If I if I have one typo here, my server's not listening for messages of this type, so that wouldn't work. But my server is listening for messages of type chat message. Send them the message as well, and then the server can, that server's event handler, that listener, is going to be triggered when that's sent. So if I open this in my browser, I'm going to inspect element, go to the network tab, just because I want to see the stuff that's going on. Refresh the page so I can see my stuff. I'm going to go specifically to the WebSocket connection. This request that has a status 101, it's going to be an upgrade to WebSockets. And we can see the messages that are going back and forth. We're going to see some messages that are set up by the library itself. So these messages, this is the initial connection. In 40, I think 40 is a disconnect. I don't know. Maybe it must not be, but I thought it was. And then we'll see these messages 2 and 3, messages of type 2 and 3. These are ping and pong messages. This is the client checking, hey server, are you still alive? Are we still good with this connection? And the server saying, yep, we're still good. So if I send a message, I'm going to send that message of type chat message with the data hello world to the server, and the server responded with a message of type ACK with the content, I received your message of hello world, back to the client. And this isn't a full chat app. We'll see a full chat app by Friday. But this is just an echo server responding with the message that I sent. And then if we go back to IntelliJ, we can see our print lines here. When we had a client connect, we're going to print out that reference to their socket, which will get some number, which doesn't mean anything to us, but can tell us if we have a unique visitor. So we have connect, that client actually disconnected, then connected again. So that's the library making sure this connection persists for us. Oh, no, that's when I refreshed. That's when I refreshed. So I got a new socket connection after the refresh, and we received a message from that client and ran our print line right here. On data, we got this message, this called received message. Data is hello world, the string that we sent. And then from that same exact socket reference, this socket is the exact same object that we received during the connect. So if we want to keep track of, okay, this user connected and sent us these messages, we want to keep track of who that client is, who that user is, we can use that socket, which uniquely identifies that connection. And if we link that to a user, if we want that user to be consistent across multiple connections, we have that available. We can build that functionality in some way. That one's a little more complicated, but and we did. Okay, so I did do this in here. So if we have the server reference to the server, which I am using for stop listener, when we built this listener, I passed a reference of the server itself. So I have access to everything the server has, which is the server, the socket.io server itself. So I'm going to say server.server.stop. That shuts down the WebSocket server. But I can also use that server. I can access the socket.io server to get a way to broadcast a message to everybody and then send that message, send some event, the same thing we did over here, but this is going to send that event to all connected users. So if we want to broadcast a message to everybody, so for a chat app to get chat functionality, we would send an event every time we receive a message. We're going to send that event to everybody.